Good morning, everyone. Welcome again for our next lesson. So we are now in Arithmetic Series. This is Sir Topper at your service. The sum of the terms of an arithmetic sequence forms an arithmetic series. The sum of the first n terms of the sequence called a partial sum. And by definition, a series is an indicated sum of the terms of a sequence. The word series can be used both in the singular and in the plural form. For the arithmetic series 1, 3, 5, 7, the arithmetic series is 1 plus 3 plus 5 plus 7. Let's have this concept. An algebraic expression of the form a sub 1 plus the quantity a sub 1 plus d plus the quantity a sub 1 plus 2d plus dot dot up to a sub 1 plus n minus 1 times d is called an arithmetic series. Let's have the formula for the sum of arithmetic series. Okay, if the last term and the first term are given, this is the formula to be used. So S sub n is equal to n all over 2 times the quantity a sub 1 plus a sub n. And S sub n is equal to n over 2 times the quantity twice a sub 1 plus the quantity n minus 1 times d, if the last term is not given. So we are given two formula in order to solve for the sum of the arithmetic series, depending on its restriction. So let's have example A. Find the sum of the first 10 terms of the arithmetic series 4, 10, 16. So let's have the solution. As we can see, a sub 1 is 4, n is 10, d is 10, minus 4 equals 6 are the common difference. Or we can have also 16 minus 10, which is also same as 6. So in here, you are given only the first term. So we need to use the second formula for the arithmetic series. S sub n is equal to 10 over 2 by substitution times 2 times a sub 1 plus the quantity n minus 1 times d. N here is 10, so we have, simplifying, we have S sub 10 is 5 times the quantity 2 times 4 by substitution, wherein a sub 1 is 4, plus the quantity n, where it is equal to 10 minus 1, and the common difference 6. To simplify further, we have S sub 10 is equal to 5 times the quantity 8 plus 9 times 6. 9 times 6 is 54 plus 8 times 5. So we have 310. So, conclusion, the sum of the first 10 terms of the arithmetic sequence for 10, 16 is 310. Let's proceed with example B. Find the sum of the first 12 terms of the arithmetic sequence 50, 47, 44, 41, 38, and so on. So let's have the solution. A sub 1 is 50. D is negative 3 from 47 minus 50, negative 3. We can also 44 minus 47, 41 minus 44, or 38 minus 41. So the number of terms here is 12. So therefore, n equals 12. In here, you are given the first term only, and there is no last term. So we are going to use the formula number 2. S sub n equals n over 2 times the quantity 2 times a sub 1 plus the quantity n minus 1 times d. And by substitution, we have S sub 12 is equal to 12 divided by 2 times the quantity 2 times 50 plus 12 minus 1 times negative 3. This is purely substitution. And let's simplify. 12 divided by 2 is 6. 100 minus 33. 33 came from 12 minus 1 is 11 times negative 3. Then 100 is 2 times 50. Therefore, S sub 12 is 402. Conclusion: the sum of the first 12 terms of the arithmetic sequence 50, 47, 44, 41, 38 is equal to 402. Let's have example C. How many terms of the series 20 plus 18 plus 16 plus so on must be added so that the sum will be negative 100? In here, let's have the given. So given are a sub 1 is 20, d is 18 minus 20, or we can also 16 minus 18, which is negative 2. S sub n is negative 100. The question here is, what is n? How many terms do we have? Let's have the solution. And again, given first term and no last term, we're going to use the second formula. S sub n is equal to n over 2 times the quantity twice the a sub 1 plus n minus 1 times d. And purely substitution, we have negative 100 equals n over 2. We don't know the value of n yet. Then 2 times 20, which is a sub 1, n minus 1 copy, and the common difference is negative 2. And simplify further, we need to remove 2 here, so it will become negative 200 equals n, the quantity 40 plus negative 2n plus 2 by multiplication. Simplify further again. We have negative 200 equals 42n minus 2n squared. Okay, so make the equation in the form of decreasing exponent of n. So we have 2nx squared minus 4n minus 200. And by factoring, we can simplify first by dividing by 2 and factor out. We have n minus 25 times n plus 4 equals 0. So as you can see, n is 25 and n is negative 4. Which is which? Can we accept n equals 25? And can we accept also negative 4 as n? Where n is negative 4, we need to reject because we're talking about the term, the number of term. We don't have negative. N must be a positive number. Therefore, n is 25. Example D. Find the sum of all multiples of 3 between 1 and 100. Let's have the solution. These are the given. A sub 1, 3. A sub n is 99. And d equals 3. First, solve for the number of terms which are multiples of 3 between 1 and 100. So we follow this or use this formula. A sub n equals a sub 1 plus n minus 1 times d. And by substitution, 99 equals 3 plus the quantity n minus 3 times 3. And then 99 is equal to 3n. Where is 3n? So we have 3 times n is 3n. 3 times negative 1 is negative 3. Plus 3 is 0. And then, divide both sides by 3. N is 33. Thus, there are 33 terms that are multiples of 3 between 1 and 100. Number 2. Find the sum of the multiples of 3 between 1 and 100. So there is the first and the last term, so we use the formula number 1. S sub n equals n over 2 times the quantity s sub 1 plus a sub n. And by substitution, s sub 33 is equal to 33 divided by 2 is times 3 plus 99. We have this. S sub 33 is 1683. Thus, the sum of all multiples of 3 between 1 and 100 is 1683. Let's have some HATS question. You may answer this. How many of the first n positive multiples of 3 must be added to produce the sum of 315? How many of the first n must be added to produce the sum of 4,950. A stack of soap boxes has 12 boxes in the bottom row, 11 boxes in the second row, 10 in the next row, and so on. How many boxes are in the stack? Let's have the skills enhancement. For number 1, find the sum of the first 10 terms of the arithmetic series 369. Number 2, find the sum of the first 8 terms of the arithmetic series 579. And number 3, find the sum of the first 20 terms of arithmetic sequences 3, 5, 7, 9, 11. Just follow the formula that we had. And for the seat work, you can answer this also. Find the sum of all multiples of 6 between 1 and 100. Find the sum of all integers between 84 and 716 which are divisible by 5. And lastly, solve. Wild geese fly and V formation. A formation of wild geese has 14 geese in the last row, 13 geese in the second to the last row, 12 geese in the next row, and so on. How many geese are all together?